If integration from -4 to 4, sine inverse sine x plus cos inverse cos x, whole divided by 1 plus x square, times 1 plus greatest integer function x square by 17, dx, equals to, ln, 1 plus pi square whole square by a, plus b into pi into, tan inverse c minus pi, whole divided by 1 plus c pi. Then find the value of a plus 2b minus c.
Pause the video right here and try the problem by your own. Don't take more than 3 minutes to solve the problem.
Here, x lies between -4 and 4. That implies x square lies between 0 and 16, right? Therefore, x square by 17 lies between 0 and 16 by 17. So from here we can say box of x square by 17 is nothing but 0. Therefore, the integration reduces to -4 to 4 sine inverse sine x divided by 1 plus x square dx. I am separating also. -4 to 4 cos inverse cos x divided by 1 plus x square dx. Now actually why it happened? Because box of x square by 17 equals to 0. So 1 plus box of x square by 17 is basically 1, right? Therefore the denominator reduces to 1 plus x square only. Okay. Now we have to consider the graph of sine inverse sine x. The graph of sine inverse sine x looks like this. Yes or no? And the graph of cos inverse cos x looks like this. Is this clear? This is your y is equals to sine inverse sine x graph. And this is y equals to cos inverse cos x graph. Okay? This is 0, pi by 2, pi, 3 pi by 2, 2 pi, and this thing goes on. This is minus pi, minus 2 pi, and this thing goes on, right? And in case of cos inverse cos x, this is 0. This is pi, 2 pi, minus pi, minus 2 pi, and so on, right? Now, it can be seen easily from the graph itself that y equals to sine inverse sine x is symmetrical about the origin. That is, sine inverse sine x is an odd function. And for y equals to cos inverse cos x, the graph is symmetric about the y-axis. Thus, y equals to cos inverse cos x is an even function. Is it clear? Now we know from the basic properties of definite integral, from minus a to a fx dx can be written as 2 times integration 0 to a fx dx when fx is an even function and equals to 0 when fx is an odd function. Is it clear? So now the integral becomes, let me rub this portion. Now for the first part of the integral, this one will become 0 because sine inverse sine x is an odd function, right? And for the second integral, it will be 2 times integration 0 to a, that is, in case of a here, it will be 4. Cos inverse cos x divided by 1 plus x squared dx. Is this clear to everyone? Absolutely. Okay. Now if we draw the graph of cos inverse cos x again, this is 0, pi, 2 pi, and so on. Now the limiting value of the integration is from 0 to 4. This is pi, so 4 will be somewhere here, right? Therefore, the integration from 0 to pi cos inverse cos x can be written as x. So the integration becomes integration 0 to pi x dx by 1 plus x square. And from pi to 4, this is any point between this line, right? The equation of this line is y equals to minus x plus 2 pi. So cos inverse cos x in the range pi to 4, we will write it as 2 pi minus x by 1 plus x squared dx. Is it clear to all of you? So we are getting from the first integration, we are getting it is nothing but ln mod 1 plus x square, and for the second one I am separating it. So we are having integration pi to 4 dx by 1 plus x square minus integration pi to 4 2x dx by 1 plus x square. So we are getting what? ln 1 plus pi square minus 0 plus 4 pi tan inverse x minus, is it clear? So we are getting ln 1 plus pi square plus 4 pi tan inverse 4 minus tan inverse pi minus ln 17 plus ln 1 plus pi square. Is it clear to all of you? Now let me rub the graph. Therefore we are getting my integration as 2 ln 1 plus pi square minus ln 17 plus 4 pi tan inverse A minus tan inverse B formula I am applying. So we are getting is it clear? Now if we compare A as 17, B as 4 and C is also equals to 4, right? Therefore the value of A plus 2B minus C equals to, so my final answer is 21. Have you understood this problem clearly? Okay.